Okay. All right. So we had started with the second chapter. With the second chapter that was about plant and animal world. We started that, and in the last class we saw about the parts of a plant, about the parts of a flower, and how plants are categorized based on their height. Okay, how plants are categorized based on their height. We saw types of roots. Then we saw the parts of a flower. Okay, now, so when we were studying about the parts of a flower, I explained to you that there are two major parts, okay, the male part and the female part. Okay, right here in this diagram, this portion is known as male part, okay, and this portion from here to here is known as female part. Now they have these names, okay?
Ma'am, I thought the
The main
anther
part,
was the male and the stigma was the female.
no. The anther and filament are the male parts. Okay, stigma, style, and ovary are the female parts. Now these male parts are called androecium. Okay, and the female part is known as gynoecium. Okay, the female part, we have three things. Okay, in the gynoecium, we have three parts: stigma, style, and ovary. Okay, this is stigma, this is stigma, this is style, and this is ovary. Okay, then in the main part and duration, we have two parts: anther and filament. Okay, this is anther, this thing is anther. This tube attached to it is known as filament. Now, androecium is the male part and gynoecium is the female part of the flower. The male gametes, anthers, are present in anther sac of the stamen. Okay. On the lower part of the gynoecium inside the ovary, there are female gametes known as ovules. Okay. You will study about androecium and gynoecium in chapter 5, living processes too. After reproduction, ovule present in the ovary produces seed, and ovary contributes towards the formation of fruit. Okay, this ovary part develops and becomes a fruit, and the ovule inside it, one of it becomes the seed of the flower. Okay, this is structure of female. This is gynoecium, and this is androecium. Okay, this is stigma, style, and ovary, and this is anther and filament. Now, please do 3.1 as homework for today. Okay, for you all to try out at home. Please turn on your videos, both of you.
Ma'am,
Yes, Abraham.
Ma'am, I don't think the male part of the flower is in the stigma. I think it's in the anther. Can you just verify, ma'am?
That's what I'm saying, Abraham. Male part is the anther and filament. It's in the anther.
Ma'am, that's exactly the same thing I'm trying to say.
No, I said that the female part is in the stigma, style, ovary. Those three things form the female part of the flower, and the male part is anther and filament. Okay, the male gametes is found in anther. All right. That's what I said. Okay. Got it now, Abraham? Clear?
Yes, ma'am.
Okay. Okay. Now, till now we talked about the plants. Now we have animals. Now, diversity in animal world. Similar to plants, we know that animals also have a huge diversity. Means different types of animals are there. We saw different types of animals around us. Now, on the basis of size, blue whale is the largest animal in which only the weight of its tongue is equal to a full elephant. Okay, whales are considered the largest animals on the planet. Okay, especially the blue whale. Yes.
Ma'am, uh, it's a full elephant is because, or it's about
Didn't
25
understand
elephants.
your.
Ma'am,
Can you repeat your? Yes. Can you repeat your question?
ma'am, is it saying it's equal to a full elephant or is it saying 25 elephants? It's because there's a picture showing 25 elephants.
It's like the weight of its tongue is equal to one elephant. Maybe the whole thing equals to 25.
Okay, ma'am.
Okay. Okay. Now, if we talk about small organisms, that amoeba and paramecium etc. are so small that we cannot see them without a microscope. Okay, so those are microorganisms. Now, some organisms live in water, some on land. Some organisms are seen flying in the air. Okay, now some have two legs, others have four legs. Flies have six legs, mosquito has eight. Okay, but what about a worm? Worm also has many legs. Okay, now body of some animals is covered with hairs, while others with scales. Some have tail, some have long horns. Some animals give eggs, and some animal produces babies. Okay, so this is the diversity.
Ma'am, only some animals produce babies.
Only some animals, most animals produce babies. Okay, but some of them lay eggs also. Okay, okay. Now we'll talk about movement in animals. How movement in animals takes place. Okay, all the animals exhibit movement. What is movement? Movement is moving from one place to another. Okay, that is known as movement. Now, movement takes place in all animals. When we studied the characteristics of living organisms, one of its characteristics were movement and sensation. Right. So now, in search of food, mate, and self-defense, they have to move from one place to another. Okay, animals have to move for self-defense also. Okay, then to search food also to mate, they have to move to another place. The method of movement may be different in different animals. It includes walking. Some animals just walk and go. Some animals roam and go. Okay. Some they run. Some animals they run and go. Some they jump and go. Okay. Some of them fly. Some of them crawl. Some of them swim. Okay. So all of these are different types of movements that takes place in the animals. Okay. Now, the method of movement in animal depends upon the organs of movement. Animals which have wings will fly. If they have legs, they will walk or they will run. Okay. Now, the animals which do not have legs and wings, they will crawl and go. Okay. So, now we'll talk more about these animals. Okay. Different types of animals categorized on the basis of their movement. First is crawling animals. Okay. Now, some animals they can crawl with the help of their abdomen or legs. Okay, the stomach area they crawl on that. Okay, or their legs. Now, in earthworm, movement is by shrinking and expanding. Okay, it's okay, Anna. Some animals they move by shrinking and expanding. Okay, if you've seen an earthworm move, okay. Now it's one move. Then the snail also same way it moves. Okay, like this.
And
Yes, Abraham.
in the second stage, what happens if the earthworm loses its balance and falls on its like this on its
Like this, yes. So Abraham, what happens is that they have a substance that helps them to crawl, okay, to hold the ground, and also sometimes snails do fall, okay. Sometimes what happens is snails, because they have the shell also, some of them, they just tend to fall. Okay. Now that time, um, they fall. They just have to like move themselves
does the
in
snake
position to
the
move.
shells crack?
No, no, a shell doesn't crack. Not by falling, but if like if you step and crush it, or if a vehicle goes over it, then it does. Okay. Then it just pushes or it just crashes, but it in itself by just flipping over it doesn't crack. Okay.
I mean, I'm falling from a height.
Falling from a height, again if it is like very normal height, okay, or even a little bit high, then they will not the shell will not break. But if it is very very high, then maybe a little damage can be there.
I'm like a skyscraper.
Okay, little bit damage can be there. Some damage can be there. Okay. Now, the
How does
sucker,
the snake move?
how does the snake move? Snake just crawls, like they do not shrink and expand, but they just crawl their body like this. Okay, they just crawl their body, drag it. They just drag it like this. Okay, on the abdomen and with the help of abdomen, and then they just move.
Oh man,
Um, how is like normally like they just drag and move.
no, I'm not understanding. It's because if you drag something, there must be some normally you would put if you wanted to drag a pencil, you would have put a wheel over here, but there is nothing to hold it. Pull the tail.
They don't have to pull it, okay? Like because they are like living things, they can do it on their own, okay? They can drag their bodies like in left and right, and then they can just move on their own, okay? Because that's how they are like created to move, okay? That's how they are like made to move, crawl, okay? Snakes, all right? And also earthworm, see, they have suckers present in their body. Earthworms, they have suckers present in their body that helps them hold the soil. Like if you can see here, suckers like this they have in the body. So with that they can make the balance.
Okay, ma'am.
Okay.
Ma'am,
Now, yes.
can you please show a video on how a snake moves, ma'am? It's because I'm not understanding.
How snake moves.
Yes, ma'am.
Okay, let me see if I can find something.
We've all wondered it at some point or another, how do snakes move if they don't have any feet? Well, believe it or not, there are actually 4 different methods of locomotion seen in snakes, and we're going to cover all of them today. The 4 different types of legless locomotion include serpentine locomotion, concertina locomotion, sidewinding, and finally rectilinear locomotion. It basically boils down to the snakes controlling the movement of different muscle groups in order to propel themselves forward. And they will use these different methods in different environments. For example, sidewinding may be more useful in a dry environment than, say, serpentine movement. But let's start with serpentine locomotion. This is that side-to-side motion that you almost always associate with snakes. And what they do is they push themselves off of a sturdy object, like a rock or a log or a branch, and then they push down where their body bends to propel themselves forward. This is also called lateral undulation. And if there's one word to remember from this entire video to sound really smart in front of other people, or if you're a kid watching, if you want to sound smart in front of your parents, learn the word undulation. This basically refers to the side-to-side motion of something, or like the wavy motion of something. That's called an undulation or undulating movement. For example, a lot of fish have undulating fins, especially knife fish. That ventral fin, which is the fin underneath the body, waves back and forth to maintain their posture or move themselves forward, and that's called an undulating fin. So there you go. The word of the day is undulation, and it's a good way to describe the serpentine locomotion found in snakes. The second type of movement seen in the snake world is called concertina locomotion. In this method of movement, snakes will reach forward and anchor the front half of their bodies down, and then they pull forward and kind of scrunch up or accordion up the middle part of their body. And then finally they anchor the back part of their body, straighten forward, and then the whole process starts over again. This is also unofficially called accordion locomotion because if you think of it, it's kind of like an accordion moving where they reach forward, they bunch together, they reach forward, they bunch together, and that's how they propel themselves forward. I like to think of it, however, as like a sideways inchworm, if that makes sense. You know how an inchworm will bunch together and reach forward and bunch together? It's like that, but sideways for snakes. Basically, they're just moving from one anchor point to the next. The third method of movement found in snakes is called sidewinding locomotion. This one is pretty self-explanatory and it's most often associated with sidewinders. This is a type of rattlesnake found in the southwestern region of the United States as well as Mexico. And what this method of locomotion entails is the snake not only moving back and forth like what you see in the serpentine locomotion, but also vertically or up and down. The snakes will physically remove their bellies from the surface while also moving back and forth to propel themselves forward. In a way, it's like walking and slithering combined. Basically, the snake uses 3 anchor points to touch down on the ground and kind of walk themselves forward snake style. This is also called lateral displacement. Lateral refers to the back and forth movement or side to side movement seen in this method of propulsion, and displacement is referring to the fact that they actually lift parts of their body off of the ground, so lateral displacement. Sidewinding is often seen in snakes that live in either very hot environments, since the movement creates minimal contact between their belly and the hot surface that they're traveling across, and it's also used in very slippery environments, like in very loose sands. The sidewinder, for example, uses sidewinding behavior to move itself forward in sand that it would otherwise not have a very good grip in. And the fourth and final type of movement is called rectilinear locomotion. This is when the snakes can move forward in a straight line, so their back or their spine doesn't bend at all, but they mysteriously seem to be hovering forward. This method of locomotion was not completely understood until very recently. In just 2017, an Ohio professor did an extensive study and was able to figure out how they're able to move and why they use this method of movement. Basically, it relies on the snake's loose belly skin. They will reach forward with their belly skin using a specialized group of muscles, and then they anchor their belly in place while the rest of their body follows behind. And this happens in many different points along the body. All the while, their dorsal skin, or the skin and scales on their back, is staying in the same spot, holding the spine in the same position, so it's basically just slowly moving forward thanks to all the movement of the belly skin below. And this is a very repetitive process. It's happening at a pretty quick rate. The belly skin is moving forward, anchoring, the body pulls forward, and then it's reaching forward again, anchoring, the body continues to pull forward, and it's just this one continuous yet very smooth motion. Rectilinear locomotion is often seen in snakes that either are fossorial, meaning they live primarily underground, or it's found in snakes that just like to burrow from time to time, such as with hognose snakes. If you think about it, a snake underground in a tunnel doesn't have much wiggle room, so it's hard for them to slither back and forth like in the serpentine method, or bunch up their bodies and stretch forward like in the concertina method, and obviously there's no room to sidewind in a tunnel underground. So really their only option is to just scoot forward in a straight line using those flexible belly muscles in the rectilinear method. On the surface, snakes will use this type of propulsion when they are feeling relaxed, and if you were to touch a snake that was moving using rectilinear locomotion, they will probably recoil and try to slither away faster, assuming they have the space to do so, and therefore they will switch to one of the other methods of movement. So that covers, in a nutshell, the 4 different types of legless locomotion seen in snakes. Again, that is the serpentine locomotion, concertina, sidewinding, and rectilinear. So I hope you all learned something new today. I think it's really interesting that we didn't understand how rectilinear locomotion worked until literally just 3 years ago. So it just shows you how there are so many mysteries still out there with snakes that we
Okay. So, hope the movement was clear now.
Yes, ma'am.
Okay. The side walking was interesting, right? Even I didn't hear about the side walking thing.
It's like the snake is walking.
Snake is walking, exactly. Like I have heard about the sideways, and then the concertina is also like there sometime, and the last one is there also, like slowly they just move without like moving their body, only the muscles. That is also there, but the side walking was like very new and interesting. So then we have, yes, Ibrahim.
How was she holding the snake?
How was she holding the snake? Some people are just experts holding the snakes and experts working with snakes. Okay, so she was just holding a snake. Okay, and friendly with snakes too. Okay. Now, flying animals. We have animals such as birds, bat, insects. Okay, which can fly with the help of wings. Then we have walking animals who walk with on their legs. Okay, they're 2 or 4 legs. 2 legs are humans. Okay, kangaroos also. Okay, 4 legs are all the other animals such as deer, cows, buffaloes, tortoise. Okay, ostrich 2 legs. Okay, and then we have running animals. Okay, who run. Okay, animals that can run 2 or 4 legs like horse, deer, tiger, and leopard. Okay, and swimming
I have a
animals.
question.
Now, yes.
How are running animals any different from any different from walking animals?
How are running animals any different
Because
from walking
they showed
animals?
a deer. A deer can run. Okay, a tortoise and a cow can't run, but they said human. A human can also run.
Human can also run, Abraham. Yes. Okay, so there is like no difference. Humans, deer, leopard also, they can walk and they can run. Okay. Only difference is the animals such as the cow and tortoise and all who cannot like actually run. Okay. But they can just walk. All right. So that is the difference. Now, swimming animals are there. Okay. We know that they have a streamlined body that helps them to move easily in water, that helps them to swim well. Animals with such shape can easily move through water currents. The fins of fish help them in swimming and change of direction also. Example of such animals are fish, crocodile, tortoise, snail, dolphin, octopus, etc. Okay. So these were all the types of animals.
But tortoises don't swim, kind of.
No, they
He's
do.
the one they showed in the picture.
Maybe not this one, but like there are tortoise which like they do swim. They live in water and they do swim. Okay. Okay, so these were types of animals based on their movement. Okay, how movement takes place, and this was about that classification. So we stop here. 3.2 is homework. Okay, 3.1 and 2 is homework for all. Movement in human body we are going to study tomorrow, Monday. Okay, in the next class. So 2 minutes break for now. Okay, please be back after 2 minutes. We will start with the math class. Okay, let's begin with the math class. Can I have your videos on, please?
Yes, ma'am.
Okay. Hello, Nathaniel. Good morning. Okay, so in the last class, we saw prime factorization. Okay, today we are going to see about HCF. HCF, known as highest common factor. Known as highest common factor. Okay, now in the last class, I explained you all that when we calculate the factors of two numbers, okay, and when we check that out of these all the factors of any two numbers, what is the factor that is coming in both numbers? What is the factor that is the factor of both numbers? Okay, and the largest. Okay, and the largest. So that will be your highest common factor. Okay, that will be called your highest common factor. Now, two ways are there to find out the HCF of any number. Okay, two ways are there to find out the HCF of any number. First one is that we do the prime factorization. Okay, first method is prime factorization method. Okay, prime factorization method. Now, I taught you all how to calculate the prime factors. Okay, let's take an example and try out. Okay, find HCF of let's take 16 and 36. Okay, now with prime factorization, what's the first thing I'll do? Is I'll take the HCF of 16 and I'll take the HCF of 36. Okay, for 16, I'll start with 2. 8s are 16, 2, 4s are 8, 2, 2s are 4, and 2, 1s are 2. Okay, then we have the HCF of 36. Again, we can start with 2 because 36 is an even number. Okay, so even number, so we can start with 2. All right, 18. Okay, then 2, because 18 is the multiple of 2, 9. Now 9 does not come in the table of 2, but in the table of 3. So 3 3s are 9 and 3 1s are 3. Okay, so we have the factors of 16. You can just write them down. 16 factors are 2 into 2 into 2 into 2. 36 factors are 2 into 2 into 3 into 3. Now, I have to find out the HCF, the highest common factor. And right now we are using prime factorization method. So first we do the prime factorization. Second, we write down all the factors. Third step is I will make pairs of the factors coming in both the numbers. Okay, 1, 2, and 2 is here. 1, 2, and 2 is here. Then both 2s are here, only 3 3s are here. So no more pairs. Okay, no more pairs. So out of the first pair, I will take out 1, 2. Out of the second pair, I will take out 1, 2. Multiply. And we have the factor, the HCF 4. Okay. I have the HCF 4. Okay, what I did, first step, do the prime factorization of both numbers. Okay, find out all the factors. Second step is you write down the factors. Okay, write down the factors. Then third step is make the pairs of those factors coming in both. Okay, if 2 is coming in both, make a pair. 3 is coming, make a pair. 2 again is coming, again make a pair. Okay, then take out 1 out of each pair. That 2 and 2 pair, I take out 1 2. Then again 2 and 2 out of the 2 and 2 pair, again I took 1 2 out. If there was another pair of 3 and 3, 1 3 out. Okay, then multiply all of them together to find the HCF. When you multiply all the pairs 1 1 out from each pair, you will get the HCF. Okay, understood how the prime factorization works? Understood, all of you? There are two methods to find HCF. One is called prime factorization method. Another one is called division method. Okay. Both will give you the answer. Okay. Both methods will give you the answer. And both are correct. Yes, Abraham.
Minute, ma'am, I'm copying the method.
Sorry, can you repeat that?
Ma'am, can you just give me a minute, ma'am? I'm copying.
Sure, Abraham. So, if you've done copying all of y'all, then just try out this question. Find out the HCF of 12 and 30. Yes, Nathaniel. I'm unable to hear your voice. Can you just put in the chat box?
Ma'am, the answer looks like it's coming to 4, ma'am. But I know it's not 4.
Okay. Nathaniel, please put yours in the chat and then I'll just solve it with you all. Anna, are you getting the answer? You can also drop your, what's the other number? 12 and 30. One number is 12, the other number is 30. Okay.
See, ma'am, the HCF is 2.
Sure about that?
Yes, ma'am. Ma'am, is it correct?
Okay. Check again.
Ma'am, it's 36.
36, no. 30, okay, 16 and 30. Are you talking about 16 and 36 or 12 and 30?
Ma'am, 12 and 30 only. Ma'am, the
12 and
HCF
30.
is 2.
Okay, Abraham. Yes, okay, Anna. Nathaniel, your voice is very low for me. Please quickly drop in the chat box. Is it 3? No, check again. Okay,
Ma'am, it's
check
2.
again. No, not 2.
Oh my god, it's 6.
Now you got it. It's 6. Okay.
But ma'am, how is it possible to be 6?
How is it possible to be 6? See, I'll show you.
Because I'm not able to get any groups minimum.
12 and 30 we had. So first the HCF of 12. With 2 we will do 2 6 are 12, 2 3s are 6, and 3 1s are 3. Okay. Then we had 30. 30 with 2 we will do. Okay. How many times? 15 times. Okay. Then we have 15. So 3. How many? 5s are 15. And 5 1s are 5. List down the factors. 12 factors are 2 into 2 into 3. 30 factors are 2 into 3 into 5. Now if you take a look, I have one pair of 2s and another pair of 3s. See, the pairs can be made like this also. Okay. The pairs can be made like this also. It's not necessary that you have to get it up and down only. You just have the number should be there. Okay. It whatever order, but the number should be there. Pair should be made. Okay. Even if it's the first digit here of the factor, 3 is coming here, and the second 3 in the other number is coming in the fifth factor, then 2 pair can be made. Okay. Then also we can make a pair. Just that the number should be same. So 1, 2, I will take out from here, and 1, 3, I will take out from here. Multiply 2 into 3, 6. My HCF is 6. Okay. Understood now? So that is how we find out the HCF. Okay. Now, can you find out the HCF of 3 numbers together? 12, 15, and 18. See, the method remains the same. Okay. Right now, I was writing here listing numbers of 2 factors. You will list 3 and then make pairs out of the 3. Okay. Like 2, you are making a pair with 2. So 2, 2, and 2 should
Ma'am,
come
is the
in.
answer
2
3?
should be a factor of all the numbers. Yes. Correct,
The answer.
Abraham. Okay. Yes, it's 3. Okay. So now it should appear in the factor of 3 numbers, then only you can make a pair. Okay. Anna and Nathaniel, please find out the answer. Are you all getting 3 as the answer?
Mom, but there is another way, right, to calculate with bigger numbers?
There is another way called the division method. I will be teaching the division method also to you, okay?
Okay, ma'am.
Are you all getting 3? No? Well, 15 and 18. Okay. We start with the smallest prime number, 2. Okay. It's coming in the table of 2. 12 is coming how many times? 6 times. Right, 6. Then check if 6 is coming in the table of 2. Yes, it's coming how many times? 3 times. So 2 and 3. Is 3 coming in the table of 2? No. But 3 is coming in the table of 3 itself. So 3 itself, 1. Okay, then 15. Is 15 coming in the table of 2? No. But in the table of 3, 15 is coming. So 3, how many times? 5. Okay, then is 5 coming in the table of 3? No. Is 5 coming in the table of 4? No. 5 is coming in the table of 5 itself. So 5 itself and 1. Then 18. Is 18 coming in the table of 2? Yes. How many times? 9 times. Is 9 coming in the table of 2? No. But 3 is coming. So 3 times, and 3 is coming in the table of 3 1 time. List down the factors. 2 factors. 2 into 2 into 3. Factors of 15. Sorry, this is 12. Factors of 15 is 3 into 5. Factors of 18 are 2 into 3 into 3. Okay, now we will make a pair. Now, making a pair, see, 3 only, I can see only one thing that's coming in both, in all 3. 3, 3 and 3. Okay, 3 is coming in all 3 tables, all 3 factors. Okay, so 3 is coming in all 3 factors. All right. What will be the answer? 3. Why? Because 3 is the only number that's coming in, that's common in all the 3 factors. Okay, so we will not multiply. Please don't do 3 into 3 into 3. Okay, no, that would be wrong. Okay, if you had two numbers coming out of two pairs, then you multiply them together. If only one pair is there, then take that number out and that only will be your answer. Okay, HCF is 3. Understood? Now, Nathaniel and Anna, how we are getting 3? Okay. So see now, there is another method to find out the HCF. Okay. Another method to find out the HCF. Were you writing, Nathaniel? Or done writing? Done writing. Okay. So I will clear the screen and I'll show you. Second method to find out HCF called division method. Okay. Now what happens in this division method? Okay, what happens in this division method? Let's take a look at an example and see. Okay. Find HCF. I'm again taking 16 and 36 so that you can make a comparison between both the methods. Okay. Now, see, first method was prime factorization. You were doing making prime factorization, doing prime factorization, and then making pairs and then taking out the common. But in this method, we will not do separately, but we take them together. 16, 36. We'll take them together. What is the catch is that both the numbers, we will multiply them, okay, until they are being multiplied by the same table. Okay, for example, 16 and 36 are both divisible by 2 because they are even numbers. So write 2. Okay, 16 how many times? 8 is 16. And 36 how many times? How many times 36? 18 times. Okay, so 18. Now 8 and 18. Are 8 and 18 both coming in the table of 2? Yes. 8 and 18 are both coming in the 2. So 2. 1 second, Abraham. Okay, so 2. Okay, how many times are they coming? 2 4s are 8 and 9s are 18. Okay, now I have two numbers that are not coming in the table of 2. Both are not coming in the table of 2. 4 is coming, 9 is not coming. What we do is we stop here. Okay, we stop here. Okay, why? Because both numbers are not divisible by the same number 2. Okay, now what about the HCF? See, then you will take whatever you have outside. 2 and 2 I was having. Those 2 and 2 we will take whatever it is outside, multiply them. So your answer will be 4.
And this method
HCF.
is shorter.
Yes, Abraham?
Ma'am, this method is way more shorter than the other one.
Yes, this is shorter, way more shorter. Okay. So, see, you keep doing the factorization, you keep dividing and writing, and if both the numbers are in the same table, like 16 and 36 are both divisible by 2. So we did 2. 16 is divisible 8 times, 36 is divisible 18 times. Write those again. 8 and 18 both are coming in the table of 2. So again I wrote 2. 8 is coming how many times? 4 times. 18 is coming how many times? 9 times. Okay. 2 4s are 8 and 2 9s are 18. Then 4 and 9 are not coming in the table of 2. So here we stop. And whatever we have outside, that is whatever factors you have outside left, you just multiply them together. And there you have the HCF. Understood this method? Okay. When you are unable to do with the same table, you just stop. Okay. Take the whatever that's outside and multiply them. Okay. Now try out. I'm going to give you some questions on HCF. Okay. Can you find out HCF of 45 and 60? Yes, Anna, you can ask. You can just unmute and ask Anna.
Ma'am,
Yes, Abraham.
I know the answer is 15, but I'm getting the answer as 45.
Okay. Now, why is that?
Ma'am, is because like when you do 3, so what I'm getting is 3 into 3 into 5.
Okay, I suggest you recheck it.
Okay, ma'am.
Okay, and Anna, you can just drop your question in the chat box if your microphone is not working. Okay.
Yeah, ma'am, I'm getting 15.
Okay. And Nathaniel, are you getting? You
Ma'am,
can
can
also
you
be.
do the sum?
Yes. Nathaniel, can you please drop in the chat because your voice is very low for me. Yes, Anna, what did you want to ask?
Yes, ma'am. I just had one doubt. So it was 45 and 60. So I did it with 5, and then my answer was like 9 and 12. So can I change the number 5 to 2 or to another number which can multiply these two numbers?
Yes, see, Anna, one thing is that you need to, like, what are the prime numbers? 2, 3, 5, 7. Okay, so when you are checking the divisibility, you like, okay, I can see that 45 and 60 both are divisible by 5. Okay, both are divisible. Why? Because 45 has a 5 at the end and 60 has a 0. So both are divisible. Yes, correct. But you need to check that before 5, is it divisible with any of the previous numbers or not? Okay, that you have to check. So first we'll take the number, smallest one that divides both 45 and 60. And if you check 3 can divide both 45 and 60. So first we take 3. Sorry. First we take 3, okay? And then with 3 we do. And then later, if 3 is unable to divide, then we will move on to 5. Got it? So you can change it. Okay, take 3 first.
But if you
Okay.
follow Anna's method, you're getting the same answer too. It's because like 45 and 60 you do, and then you get 3 and 12. Then you divide 3 and 12 by 3, which will give you 4 and 3. See, 3 and 4. Same thing.
Okay. But still, I'd suggest you, I'd prefer for you to start with the, like, go from small to big, okay? That's what is usually followed. Now 45 and 60, just to show you all. 45 and 60. If I take with 3, Nathaniel, how many times 45 is divisible by 3?
$15.
15 times. Very good. And how many times is 60 divisible by 3? Yes, Nathaniel.
30 times, ma'am.
30 times. 30. Okay. Now, can 15 and
Ma'am, this
30
is the
be
mistake.
divided by...
Ma'am, it's not 30, it's 20. It's the same mistake I did.
Oh, okay. Yes. We are dividing with 3. Okay, correct. Abraham, correct. 20. Because it's not 2, it's 3. Correct. Now, 15 and 20 both cannot be divided by 3 because 15 I have in 3's table, but 20 is not there in the table of 3. But 15 and 20 both are in the table of 5. Okay, how many times? 5 3s are 15, 5 4s are 20. Now, can 3 and 4 be in the same table? No. So we will stop here because 3 and 4 cannot be in the same table. Outside I have 3 and 5 multiply 3 and 5, how much? 15. Okay. So this is how we solve for the HCF using division method. Okay, this is your HCF using division method. Today I'll send you some questions to try out using the prime factorization and division. Also, you can try out the questions from your book too. Okay. HCF 1.8. Try out 1.8 question 1 only. Because question 2, I'm yet to explain you that method, comparison. So 1.8 question 1 you can try out for the homework today. Okay. Okay, Anna, we are just ending the class. See you on Monday. Have a good weekend.
Thank you, ma'am.
Okay. Okay, Abraham, Nathaniel, please do the homework. I'll also see you guys on Monday. Okay?
Bye, ma'am.
Okay, bye. Have a good day. Yes, Abraham, you're muted.
Ma'am, I have a question about the homework. Ma'am, did you check
Yes.
did you check the homework, ma'am?
Your homework? Not yet, Abraham. I haven't checked it yet.
Ma'am,
Okay.
it's because in my homework, ma'am,